In this video, we're going to go over the odd number problems on the step function exit card. A lot of you expressed difficulty with this exit card, so I feel if we go over the odd number problems, you should be able to do the even number ones pretty easily and then be successful on this assignment. Okay, so here on number 1, it gives us the scenario that you want to park your car at a metered space on the street. And the sign says 75 cents per hour. Any fraction of an hour is rounded up. So here the key part is the rounded up. So what type of function best models the scenario? They give us two options, a ceiling function and a floor function. So if you think about a house, the ceiling is going to be up at the top and the floor is going to be at the bottom. So if we are rounding up, we're going to the ceiling. So this type of function where you round up is called a ceiling function, and in a floor function, you round down. So that one was pretty easy. Let's go ahead and look at number 3. Now they give us the graph of a step function, and they want us to determine the value of f of 4. So we're saying here, when x is 4, what's our y value? So what is y equal to when x is 4? And we can figure that out by figuring out what the y coordinate on our graph is when x is 4. So we go over here to where x is 4, we look up. So here we have two possibilities. We have the hole here at 5 or the closed circle at 6. So when you have this scenario, this is called a jump or a gap. You always want to take the value that has the closed filled in circle. In the open circle, you're saying we're not including that number. A closed circle says that you are including that number. So here, when x is 4, y is going to be 6. So our y value is 6. So f of 4 equals 6. So hopefully you should be able to do number 2 and number 4 after looking at that. So let's go ahead and take a look here at number 5. So given that g of x equals these weird brackets here that we have with the x on the inside. The important thing about these brackets is that they have little lines or hands on top. And if you think about that house again, the top is a ceiling function. So that tells us that this is a ceiling function or a round up function for x. So they want us to determine the value of g of 4.1. So we're going to round up 4.1 to the next whole number, and that next whole number up would be 5. Okay, last but not least, we have number 7, and it says select the equation that describes the graph below. So we're given 4 different types of equations. They either have a ceiling function or a floor function in this part, and then we have +1, -1, +1, -1. So the first thing that I would do is look at my x values. So right here, I have a point that is at 1.5 on the x, and its y value is 0. And here, I have a point that's at 2.5, and its y value is 1. And up here, it's kind of hard to see. I have a point that's at 3.5, and it has a y value of 2. So the first thing that we're doing here is we're rounding down. All of these values here between 1 and 2, they don't round upwards towards 2, they're going to round downwards towards 1. So we know that this is a floor function. Also, floor functions go up at the right open circle. A ceiling function has an open circle on the left and a closed circle on the right. So that's another way to tell the difference between a ceiling and a floor function. So we know it's a floor function, so it can't be B and it can't be C because both of those have the little hands on top. So that means it's a ceiling function. So once we round down, so let's say 1.5 rounded down to 1, 2.5 rounded down to 2, and 3.5 rounded down to 3. Now to get our y value, we would have to subtract 1 from each of our x's. 1 minus 1 gives us 0. 2 minus 1 is 1. 3 minus 1 is 2. So here our answer is going to be D. We start with taking the floor function, the round down function, and then we subtract 1 to get our y value. If you're still having trouble with these, please email me or post on our live Google Doc and we can work more on this together.